recording, and I will share screen with the notes that we have up for the academic session so far. Let me see here, screen 2, there you go. Okay, cool. So for anybody who wasn't present, I think we have a lot of overlap with the live coding hacking session earlier today. There was a lot of really interesting concepts discussed, and we did a pretty thorough rundown of the kuma mapping software, or graph network software, sorry. So yeah, definitely feel free. We'll have the recording from that up in these notes. And yeah, happy to move into the academic discussion session. And so far, we just have a couple of points on the agenda, so I'm happy to popcorn any other topics if anyone has particular areas of interest. So far, we have an agenda topic of exploring the existing areas of research that have been uncovered in the Token Engineering Academy thus far. I know some of that discussion was also had in the hacking session earlier today. And then we were considering chatting further about exploring the reduction of computational complexity of quadratic funding using linear algebra techniques. So if there are any other agenda topics, I'm happy to add a few here. Otherwise, we can dive into some of these topics and see where they lead us.
Sounds good.
Cool, works for me.
Cool. So I know there were a couple of topics in the hack session this morning. Actually, I'm not sure the link for the Miro board where all of those research areas were linked. Does anyone have that? Danilo, I know you had it up earlier today. Maybe Angela, do you have the link? I can either pull it up or happy for you to share screen, either way.
Yeah, there is a PDF in the Discord channel. I've uploaded it yesterday, and there are the results. Give me a second. I can also pull it up. Actually, we had a workshop on, let's discuss research questions. Let's see what people in the group are interested in, and also the various backgrounds and expertise that everybody is able to add. And we had some really interesting directions, and I think this is a perfect opportunity to gather some feedback on the topics we had in mind. Should I pull up the entire collection again?
I've got the PDF open here. Can you see it on my screen?
There you go. This is it. Just to give an impression. So overall, still scope is optimized quadratic funding, collusion, Sybil attacks, Matthew effect, those three directions, and then subtopics, and also approaches how to find new solutions. So perhaps we can just open the stage, since Jan, Irvin, Quette, Octopus are here. If you want to present your research question, just throw your ideas and collect feedback. This is your chance, basically.
Maybe I can ask something. Can you hear me? Perfect.
Yeah.
So the first research question I had was, how can we quantify the saturation effect on grants contribution behavior? And my initial thought to start this, because that's kind of like my biggest thing, is like how to actually tackle this kind of a question, right? And the way I would think about this is that, like, we can look at the cadCAD model, like how it performs with all the matching and so on, and then we detect when the saturation point, and we compare the before and after of grant behavior. Would that be a proper way to tackle this issue, or do you have some other approach, or some more sophisticated stuff?
Sorry, can you repeat the how to? So it was regarding the saturation point. I didn't catch the beginning part of that.
So how to basically detect the before and after, right? So for example, even if you theoretically, let's say, can detect, okay, at this point all the matching amounts are basically like distributed, right? So from now on, it's just a negative sum game, right? So what kind of properties could we look at to compare before and after?
Cool. Awesome. Yeah, happy to discuss that further. Are there any other interesting research areas that were discussed in the Token Engineering Academy space? And actually, while we're chatting about them, I'm going to pull up, or it's, yeah, okay, here we go. This was the Kumu map that we drew this morning in our interactive hacking session. I'm reading some of these as well. And yeah, really interesting exploring Kuma mapping tool. And we see the some of the agents, some of the areas of interest of research, and some of the token engineering ideas have been discussed and already exist on here. So I'll drop this link into the notes as well for anyone to explore. But yeah, happy to open the floor to more research areas and interesting questions.
Yeah, can I ask something as well? I put together a copy of my research question as Angela suggested by templating from Danilo's ones. Maybe I can share my screen to show that.
Absolutely.
Can you see this?
Yep, perfect.
Okay, so it's a slightly other way of looking at networks and basically the emergence of networks. I like the idea of taking the plunge into subgraphs. However, I don't know anything about it yet. But this is, of course, interesting for me then to explore. And my main idea is how can I see the emergence, or how can I look into the emergence of subgraphs over time during a round or in between rounds? I put it somewhere here. I call it emergent strategic behavior. Of course, you as a research group are investigating the optimality gaps and this kind of stuff about quadratic funding and how you maybe should tweak or alter the algorithm in order to get that right. But my approach is slightly different. I'm interested in looking at the dynamics of the behavior of the contributors themselves. So apart from all the quadratic funding or matching stuff, I would like to investigate how contributors actually behave during a round or in between rounds, because several contributors are, hopping from one round to the other, and maybe they show some sort of recurring behavior. So basically, my hypothesis is that contributor behavior will change over time, and I think that certain patterns will arise during that round and into three clusters. Of course, I'm guessing this. So you have the early adopters or the contributors kicking off the party, so the first movers, and they maybe can set the scene for the other ones. So this is interesting to look at from a time step perspective. Yesterday I showed you can tweak around a bit with the bipartite graphs in the network notebook. Uh, as you can see here, at time step one, there's one contributor already staking at 10 different grants. And then you can show, well, how this is moving ahead. So I guess there will be three, maybe we will show three clusters. So kicking off the party, the early adopters, the guys late to the party, holding to the max, looking at how others will stake, and then put their stake somewhere most of them will put it. But the interesting cluster is, of course, the alliance cluster that are moving around during the round, forming some sort of alliances, obfuscating maybe some colluding behavior. We don't know yet. This is something I would like to investigate, but I'm not sure if I'm going down the right alley here.
Awesome. Well, I think this is definitely the group to run these ideas by. So happy to have this as a topic to investigate further as well. Cool stuff. Would you mind dropping a link to that HackMD as well, just
Yeah,
so I can drop it in the notes? Thank you.
yeah, sure.
Sort of an interesting theory there about the three different clusters of funders. You know, the people who kick off the party, the people who are just watching the mean, and then the ones who are showing strategic things. I wonder if that's, so there's a way to prove that out in the data set. It's an interesting idea.
Thanks.
I was also thinking about some of the questions you've posed and around maybe as a baseline to conviction voting, because a lot of those are sort of built into conviction voting models.
The bipartite graphs, you mean in particular?
I think just more on the questions of like who's holding, how long they're holding, and so just looking around how that might. I mean, if you're going to make inferences from that, and you might want to then compare it to a model that is incentivizing long holding for conviction. So your inferences then could be built around convictions using a different model.
Cool. And yeah, I just want to bring up a point about conviction voting, and also something recently I saw from RMIT called commitment voting, which I think be along the lines of what you're saying is the more time that you lock your tokens, the more weight they have. So it's still a distribution of your weight, your voting weight in space. Conviction voting brings the temporal aspect to it. So you can have both an allocation of weight kind of in space and the effects of that weight unfolding over time in conviction voting. So interesting to look at some of the composability of these primitives and in different use cases as well, like in the grants quadratic funding case.
It's weighted time space.
Yeah, exactly. Cool. Were there any other thanks for dropping in that link. Any other topics from the Token Engineering Academy side that we should have on here? And we don't have to get through all of these topics today, but just, yeah, really interested to hear a bit more about high-level, exciting research areas from the Academy.
Hi, I hope it's not too loud here. I have one thing I want to share as well. This is sort of relating to some of the stuff that Mark was talking about. It sort of ties in with some of the brainstorming that I've done. I just had this little nugget of an idea that maybe like sort of generally speaking, nefarious actors will act nefariously in all situations. So when there is I got this idea thinking about the situation, like if the game changes from a whatever it is positive sum game to a negative sum game, um, before and after the saturation point, then you might be able to recognize like optimizing behavior in two games, and so maybe that could be like a sort of telltale giveaway sign of like people people who are going to act nefariously are probably going to be thinking about strategizing, right? So that could be a, I don't know, an interesting little book.
I'm having a bit of trouble. I don't know if it's your audio or some background noise or something, but I tried to capture that. Basically saying that there are different games between like before the saturation point and after the saturation point when it moves into kind of the zero sum dynamics.
So I'm using the saturation point as an example, a potential example. But yeah, like hypothetically, maybe you could be able to identify people acting strategically if they, if the game enters a different phase, and you see their behavior adjust to be optimal again in the new game, in the new set of rules or whatever.
Yeah, I'm a pretty big fan of looking at temporal dynamics as sort of ways of identifying different characteristics of behavior. So I tend to agree with you. I think there's a lot to be explored still, since we only really got the temporal traces of the data sets recently. So when we first started, built our cadCAD model, and the cadCAD model actually traces through the sequence of events and therefore gives us those trajectories or those traces of the network coming into existence. And although we're still working on our collusion algorithm, which is sort of snapshot oriented for computational reasons, for complexity reasons, I think that it's a really good research direction to explore the sort of the traces of behavior and sort of making inferences based on, again, like to your point, changes or things that seem to express a pattern that's distinct from the everyday users in the way that, say, one strategy switches, or it's possible that actors only act before or after the phase shift, for example. Like, it might not make sense to try to do an attack any time other than at the very end because you have the most information. So from like a dynamic optimization strategy perspective, if you're trying to solve to maximize your take, and you're going to be able to do that by leveraging the structure of the graph, then inevitably you would want to make those moves at the very end when you have the most information. So it's a little bit the opposite in the sense that the optimal strategy in that setting is to wait and go at the very end, but it still is inherited from understanding temporal dynamics and the way those temporal dynamics affect optimal behavior.
That's super cool. It's very cool.
Awesome. So I think we have a pretty good list of topics. Oh, sorry, is there another one? Go ahead.
Oh, I was interested in sharing my screen if I could.
Absolutely.
This, and I want to, can you see my screen?
Not
I
yet.
don't
No.
see it yet. There it is.
Okay. I live in a very rural area with very poor internet, so I'm just praying that you'll get good signal. Um, so this is something that Danilo and Danilo has helped me with, would probably be a better characterization, but in terms of investigating the optimal subgraph or the optimality gap, in the definition of the optimality gap, there is a notion that we can determine the optimal subgraph. And
A quick question: can
so
other people see it?
for
Because
me personally,
I'm still seeing little like rotating circles, which means it might be trying to upload too high of bandwidth. I don't know if you want to. Oh, never mind. It just showed up. Sorry, it took a few minutes, but
no worries. No,
it just
yes, I have very bad internet. I live in a very rural area with very, very slow internet, unfortunately.
well, it showed up now. So unless
So
other people can't see it, I think you're good. I would be careful about
okay,
scrolling too fast, though, given that dynamic.
you. So in terms of the optimality gap, it was it's defined in terms of an optimal rewiring or an optimal reparameterization of the graph. And so to address that dynamic, we don't actually know what the optimal rewiring is. There may be conjectures or heuristics. So question that I was interested in was using analytical tools to actually set this up as a problem through solving equations that might place a limit on so tools like convex optimization, which I have seen, I'm certainly not an expert in, but or something even like Lagrange multipliers with the right formulation or knapsack problems. There are lots of ways that one could approach finding the optimal subgraph, and maybe serendipitously, the same day that I started this, I went to another research talk in another area where they were talking about solving very large systems of quadratic polynomials in the order of thousands of variables, and that's feasible now. So I think that not at the scale of a real world data set, but at the scale of a toy problem that might still yield insight, that it may be possible to determine the exact analytical optimal subgraph that we're searching for. And then we could compare that to the optimal subgraph found by the meta-heuristics. And if they're close to each other, then that's great. That means the meta-heuristics are reliable. And if not, then that gives us another insight. But I also don't want to. So I joined this project hoping to meet people and learn things. So if I'm the only person who's interested in this, or if it doesn't have high value to the community, I'm happy to jump on someone else's idea. But this is what I thought of.
It's a good idea. I'll give definitely big thumbs up. I don't know. I've just sent you a message. Like, I actually taught convex optimization at Penn. Like, it's definitely the right toolkit. May not be the only toolkit, but it's a good place to start. In fact, part of the reason we discussed in a previous call about the linear algebraic formalizations and the graph representations using like essentially like the algebraic or vector space and vector matrix representations is because that's the sort of representation of the rewiring problem that you would need in order to access the benefits of convex optimization. And that also leads you towards more linear algebraic solutions, which tend to be faster. So I actually think that some of what you're suggesting dovetails reasonably well with some of the other research that Danilo and I had highlighted around the sort of linear algebraic sort of specification of the same problem. It will match with the interest to use convex optimization as a tool. And a really nice thing about convex optimization is that those problems are they're in P, not in NP. So combinatorial problems are inherently difficult to solve, whereas algebraic, well specified convex algebraic problems are quite fast. So if you are able to sort of find the mappings, or if we're able to find the mappings, we get a lot of improvements. So big thumbs up from me.
It's also possible that if it's not feasible to optimize the actual quadratic matching function, that there may be a good approximation whose maximum occurs at the same place. When you're dealing with increasing functions, you can usually replace variables here and there, and you'll find not the same maximum value, but that the location of the maximum is the same. So you can often replace the exact optimization function with an approximate optimization function that gives the right solution.
In the overlap related to this concept called submodularity, where even if the things you're optimizing over are set based, due to the sort of monotonicity of the function that you're optimizing over, you can sometimes still recover exact solutions.
All I wanted to share. Thank you.
That's really awesome. Sorry if I was like, jabbering at you. This is definitely in my area of interest, and I think overlaps with some of the stuff Danilo and I have been discussing. So, I'll just sort of yeah, double thumbs up
Oh,
and let me know if you have any questions. You can DM me if you want.
excellent. Thank you so much.
Awesome. So are there any other topics that have come up, research topics that have come up in the Token Engine Academy space? I think we have a ton to talk about here. Actually, in our session earlier today, we were talking about the potential of even breaking out in sub-work groups if we need to dive deeper on any of these topics in particular. Yeah, so happy to keep putting down some further ideas, or we can move into the exploration of computational complexity using the linear algebra approach, which I'm not sure if that ties in with the sort of approximations that provide that optimization without the computational overhead that you were just mentioning, Octopus. But yeah, happy to field some more topics as well if there are.
I'm see how linear algebra is used here. In general, matrix multiplication has complexity that is not as nice as one might like. So it's if they're sparse matrices or something, there may be advantages, but I'm curious to see what happens. That's my comment.
Yeah, so it's interesting because matrix multiplication is, potentially sort of n squared for square matrices, but it's still um, polynomial compared to combinatorial problems. So if you're reducing a problem to something that can be solved through matrix multiplication, you're still doing better than you would be if you were optimizing in a pure sort of combinatorial search space type problem. But to your point, sparsity matters a lot. And one of the cool things about the Gitcoin collaboration graphs is they are actually relatively sparse. You can view them instead of instead of like an n by n dimensional problem, you can look at them as n by m, where n is the contributors and m is the grants. And even that is sparse because the n contributors don't contribute to all m grants. So you can pretty naturally construct the representation using a gram matrix. And a gram matrix is a matrix that you get from taking a transpose with itself. So if you have the contribution graph matrix, which is n contributors by m grants, then you can do the n times m times n to get an n by n gram matrix, which is going to be symmetric, and it's going to contain information about the coincidences between the different n uh, users donating. And if you do the reverse, you get an M by M matrix that tells you something about the overlap between two grants. And furthermore, you can use those same constructions to create Laplacians, and Laplacians are largely used for different, like again, these sort of algebraic graph measures, and you can look for things like eigenvectors and Laplacians to detect interesting features in graphs. And this is the kind of technique that actually ends up coming out when you solve convex formalizations of optimization problems on graphs. So sort of intuitively, this is sort of the direction that would come out when you start working on again, these algebraic, the representations of the graph optimization problem. And I know I'm talking a lot of math. If we wanted to look into it, I know Danilo had started to put together a set of definitions that we were using to sort of bootstrap in this direction. But I also don't necessarily want to impose that topic on everyone because we present a lot and we wanted to make this more inclusive.
Perhaps we could have a math working group because I think going through the definitions carefully would be very important. And it's something I'd really be interested in doing. I agree with you, it's probably not a generally interesting topic. So perhaps we could set up a specific math working group at some point.
Well, that's my jam. These are
And let's make sure that we still share it, because even though not everyone might be able to contribute, nevertheless, it's important to get the picture. So cool.
Absolutely. Yeah, I think a lot of that, those mathematical formalizations kind of build, that's the foundation that we build other parts on, including the cadCAD model and more. So it's just that I agree the definitions can be a bit mathematically intense. So
So
yeah, go ahead.
as we do the definitions, I think a good pattern to propose would be definition, example, so that there's a visual or kind of like multiple modes of representation. I realize that mathematical writing tends to err on the terse side, but perhaps there could be multiple documents written at multiple audiences that are kind of doing the same idea but in different things. That would be my thought.
Oh yes, Sandro. We had a discussion on that. That's why I'm so happy.
I mean, math, I think my experience is that in order for math to become useful and legible, we often have to do sort of two layers of work. One, to sort of do the formalisms from the, symbol pusher mathematician's perspective, and then do like an entirely separate exercise to make it legible and tie it into the coding, to the, other stakeholder. Like, it's a language. It's very much best thought of as a language. And so if you have to translate to multiple audiences, then one has to include that in the broader workflow.
Great.
Is there anyone else, just so I've taken a couple of names here for who would like, well, I guess we can drop updates in the channel, but is there anyone else really interested in being part of that math working group?
Yeah, I'll
Yes,
take
me,
part of that.
please.
Roger and Corte?
Yeah, I'm not a math ninja, but engineering vibes, I can, and yeah, Laplace level, stuff like that, but no PhD. Hopefully I can keep up.
You're a
PhD is
ninja
not
in many
required.
ways.
Yeah. Definitely PhD is not required. If you think about mathematics as a sort of more of a literacy, the only way to get stronger at it is to exercise it.
Cool, I'm game.
Very cool. Awesome. Okay, so are there any of these topics that we kind of a surface level exploration, or any that there is overwhelming interest to deeper into with the remaining time? We have about 20 minutes left. Or if there is, I know Z, you mentioned wanting to open up some community research, but yeah, there is definitely some interest in the linear algebra formulation of quadratic funding as well. If there's anything who wants to delve deep in that, or we can go into any of these topics and have a bit more conversation. Any preference?
I mean, this session is really meant for the attendees, so I mean, I don't have a preference. I think the key here is to start like drawing people in, and if that means that we're continuing to sort of present some of our stuff to help people get comfortable, and that works. But I think we're going to make a habit of these sessions to like always start by offering other people to suggest topics or to bring work before we go ahead and share ours.
I mean, I'm not sure, Jan and Mark, you have introduced your topics quite briefly, but I feel at some point it might be cool to brainstorm on how to approach this. Up to you.
Yeah,
Yeah, I
I
can.
was actually Go on.
Yeah, sure. Yeah, sure, Angela, you're right. Because this is actually the idea of presenting this to this group. I'm not sure where to start with this stuff. I'm pretty new to subgraphing and this kind of networking stuff. I might be able to infer something about the existing notebooks, but then again, well, I need some help starting up.
Yeah, I think this is a valid question because I mean, one of the things that I was wondering it was exactly, let's say, how you can define it, those clusters. And another thing of note and is also that the context is also to analyze the data from the outer rounds. Right now we have for the rounds 7 and 8, but for the outer rounds perhaps we need to get the data with Gitcoin. By the way,
Yeah.
Awak, do we have access, for example, for data for rounds 5, 4, 3, 2? Maybe we could get 10 and let's say, get out the personal data so that we don't have any the ox problem, and maybe we could share with people.
Yeah, I could really use some more data about these former rounds, like 6, 7, and 8, and I think there's still around 8 and counting or something like that. I call
Yeah,
it 8 plus. Yeah.
that's totally fine with me, Danilo, as long as we don't dox anyone. The the grant CLR table will have the round dates in it, and the contributions table will have the data in it, so we can do a pull of them for each subsequent round if it helps the group.
Yeah, it would be very nice to have.
Okay, so if I understand correctly, though, we're gonna need to grab that Danilo probably from Owaki and do our own scrubbing pass, and then once we can kind of like attest to the sort of DPIing of the data, we should look at a way to host it in a way that makes it pretty easily accessible, so that other people can pull it. I mean, we can deal with that separately, but I think that's probably the best procedure, since that gives us I know we have other stuff to do, but that's a good way to make sure that we don't dox people, is that we'll sort of process the data sets, PII them, and kind of confirm that we've done that with Owaki, and then we'll make the resulting data more available.
Great.
Yeah, I agree, and especially because we could use the data on the cadCAD model. So I mean, we could even use other rounds data as a testing set for. I mean, there is more open data is never bad.
Cool, cool. Are there any thoughts on other next steps other than access to the data? Where Mark would start to dig in to understand some of the implications of this? Danilo or Z, any thoughts on other starting steps?
I mean, I'm not 100% sure, but this is sort of making me think that there could be a really valuable contribution if someone wanted to try to like help us figure out what's sort of the quick start guide to Gitcoin data science, essentially, because it's a cool topic. It's got a really cool value proposition. A lot of people share in the value of Gitcoin. It's got data scientific aspects. It's got modeling aspects. It's got simulations and network science. So obviously everyone's here, so they think it's both cool and cool and or important. And I realized with this question that I don't really have like a great start here from a like from an onboarding perspective, because we just really hadn't tried to answer that question before. So I wonder if even just like defining what a starting point would be that makes this maximally accessible, and like working to have a quick start guide. It could be a community project of some kind, obviously with help. Like we wouldn't just throw you out on the to do it, but I'm not sure what that quick start guide would look like, because we dove into it with a bit more prior expertise in the related topics, and so the on-ramp for us is probably a little different from what a general person coming to the project might need.
Yeah, I can imagine. I'm very impressed by what Jan was presenting yesterday. Maybe you can team up with Jan for the data science part if we have the data to get some grip on that, and then I might be able to get around. So no problem.
Yeah, I'll admit that probably the single biggest thing that this project has been doing for us as a team is sort of helping us figure out how to make some of the work more legible, because we do a lot of work behind the scenes in a lot of projects, and it leads into some analysis or decisions or designs or whatever, but the body of the produced work tends to be sort of in the behind the scenes somewhere, and that like the effort to get more people involved and interested in participating requires a lot of work on legibility, and that's not something that necessarily our strong suit. So we're trying to evolve with you guys all to to create more sort of as Danilo says, like open science, but that includes the tools and the methods and the opportunity for people to onboard themselves and not necessarily require hand holding.
Yeah,
Yeah, well,
I agree.
sorry.
Yeah, go on.
Yeah, as I said, I think I can figure it out once we have the data together with Jan or other guys from the course. No worries.
Very cool. Awesome. Any other? We have 10 minutes left, or just over 10. Sorry.
So if you want some feedback on what it's like for maybe the like not average user of this forum, but for an average person maybe to see what this is like, I could ask one of my students who's a math CS double major, graduating next year. They join and see what they can make of what it's like to get started.
Great idea.
Well, I mean, if we're good, we can always call it early. I maybe have one last question, which is, do we want to try to do the math session during one of these sessions, or do we want to try to schedule it separately? I'm inclined to do it in the recurring session, but then sort of tell people in advance that the plan is to do math stuff, rather than try to find yet another time for many people to kind of coordinate around. But I want to make sure that that's sort of acceptable to people, before sort of committing to do that.
So from my perspective as a complete newcomer, but I think that meeting with the math session during this time, but then encouraging people to come, might give the mathy ones of us some insight on what we need to communicate clearly. So obviously, much of what we say to each other when we speak math to each other is not necessarily comprehensible to other intelligent people who aren't mathy people. And so if someone says, wow, that made no sense to me, that gives us a bullet point that this needs, for a typical user of this forum to understand this idea, this will need a different representation. And even like it's a way to test our explanations. Like if someone says, what does that mean? And we say it means this, and they say, and they can give honest feedback that made no sense to them, that would be incredibly helpful. On the other hand, that would obviously slow down sort of the mathy conversation. So I guess it's a question of value in that sense.
I might be that person that can maybe be the bridge between the non-mathy people and the very mathy people, and maybe make a phase 2 to the non-mathy people. I haven't done proper math in a long time, so yeah, I might be that bridge.
You know, and honestly, my hope is that this community can also help function it more broadly as that bridge, because my experience with the sort of, again, token engineering field is largely, crossing the threshold from the sort of mathematical domain where you can specify and assert algorithms with strong properties or that relate to some goals, and manage that gap between reality and the models that you're using in your code, because code always sort of has implicit models even if it doesn't have explicit ones, with the sort of implementation level, like writing code and getting it to work and using it to make decisions, and then like the experiences of people using those platforms. So at least in my opinion, the token engineering community is like collectively kind of going to be the stewards of that relationship between sort of design, development, maintenance, and governance of these data driven, automation rich platforms. And kind of with that in mind, I think Roger, like, this is super important for all of us to learn to do. So I would probably agree with Octopus that it's worth doing it even if we have to move slow.
Sure, I was thinking I'll be the guy going, what does that mean? Quite a bit. So
For sure.
Not sure if we have some minutes left to introduce some more questions in case Sean and Matt, you'd like to share some of your thoughts, or maybe, I don't know, if you have already nailed your questions.
Yeah, sorry I was late, guys. Work stuff. I have no idea what my question is going to be. I'm still very much feel like I'm trying to get up to speed. So I'm definitely interested in any like math working group. I feel like very similar to Roger, in the same boat where like I come from a formal math background, but like I haven't done it in a long time. So I'm really feel like I'm just trying to wrap my mind around the problem and understand it in the terms that everybody else is talking about. And I threw some questions out there, some things I was interested in, but I mean, this is like getting up to speed here is like not that trivial. So yeah, I'm still really the fact that you guys are talking about this is encouraging.
I'll put that as an extra +1 to the focused on onboarding and legibility and making this work overall more accessible without, again, sacrificing the technical. So like helping people get from join to I understand this seems like the most important thing that we could do.
Yeah, for sure. I feel like there's just a lot to sort of like I feel like when we listen to Danilo like in his sessions, like he's been in this for seems like a few years, and he's deep in like graph theory and like a lot of things that are like you can sort of pull up to speed like relatively quickly to know what's going on, but to be able to contribute, I think, is another level. Yeah, so that's kind of what I think. At least like for like I'm a total newcomer. I know Octopus is like a total newcomer, so for guys like us, it's like that's very tough, even though we're all relatively technical.
Yeah, I guess a point I'm trying to make is that these sessions exist to identify and close that gap, right? Like, if we were just trying to go full speed ahead, I mean, honestly, we have our own internal sessions for our project. We are doing a project, me and Danilo and Jaja and some of the members of the Block.Science team, and we're going to continue to run sort of full speed ahead on that based on the needs of the Gitcoin platform and like our relationship with them. But these sessions with the token engineering community are as much about transferring knowledge and like learning to communicate and collaborating as anything else. So sort of understand that it's not a problem that we need to slow down and work through stuff. It just needs to be identified so that we can accomplish this goal of making those fields more accessible, making it easier for people to understand how to practicalize them. Because I think one of the reasons people haven't used some of these methods for some time is they haven't been given a clearer path between their formal mathematical skills or education and the practical problems they face on a day-to-day basis. And if we can help fill that in, then I think we can sort of unlock those skills too.
That sounds awesome.
Hey guys, I'm sorry I'm late as well. I had some conversations the other day about some projects I was interested in. I was talking to 4D with 3Ds. Now, I don't think I see someone else in here, ddd.ddd. I don't know if that's the same person or a different person. But but we were talking about using AI in the to find sort of collusion patterns. I find that interesting, but if there's not already some momentum on that kind of project, I don't think I would want to spearhead it. Can we, I'm sorry I'm late, but can we just kind of quickly scroll up? I'm not sure where this doc is. It's probably in the one-stop shop, but I don't have it open. So maybe let's just, oh yeah, Jeff's gonna share it. That's awesome. So what was the other one I was interested in? Is someone looking kind of on the math side, but I could be like programming hands on a math project. I was interested in this idea of like alternative functions for the quantitative funding. I know Irvin was talking about like this idea that the sigmoid function looks kind of familiar, going through some of this math, and like would we be able to swap out these kinds of functions? That's pretty interesting to me. And I think Nico is away today, and I know he was looking in with TJ, about the sort of metadata stuff, like alternative metadata, and TJ has that data scraping system that he put together. But I think for myself, my priority would be the AI for collusion detection if there's already some momentum, and if not, I think I'll want to join one of these like kind of more formal teams that's looking at some of these alternative functions. So yeah, that's awesome. I think you got my stuff there. That's great. Thanks, Jeff.
Quick question, YG Anderson. In particular, what kind of models were you looking to use? Because I recall you mentioning reinforcement learning.
Yep, that's what I would ideally be looking at. I'm working also, I'm kind of Mark has a project on the go, which is reinforcement learning in energy web simulations using token spice. And so if I had these two different like reinforcement learning projects on the go, that'd be kind of easy for me. It'd put me more in the mindset. So if anyone is interested in this reinforcement learning for like finding collusion patterns, then yeah, I would find that super interesting.
Yeah, I'm
I mean, I'd
definitely.
love to discuss more on that too. I just don't see the RL part yet, but I'd love to discuss with you more on that on the side.
Sure, yeah, I think it could be, I mean, I don't have it fully fleshed out, but we would just have to define a reward function. So almost like this, we could reuse the optimality gap.
The reward function would generally, in this setting, be the actual matched funds, or
Yeah.
at least the efficiency, sort of the matched funds per fund. The challenge that you get into, though, is if you're modeling a reinforcement learner against that, you're actually effectively modeling an attacker. So what's
Yes.
interesting is you would be taking real historical scenarios or synthesized artificial historical scenarios with counterfactual scenarios using some of the data from the previous ones, the real ones, and then you would be running repeated simulations, and you'd let your attacker play, and they would play with a strategy that was learned through the reinforcement learning algorithm. And what you'd really be doing is training an attacker. It's an interesting idea, though I'm not 100% sure how you would use it to detect collusion. It's more effective for training a colluder. So, I mean, I guess the open question would be like, if you could train a colluder, you could use it to sort of find optimal strategies quickly and then thus measure optimality gap more efficiently. So there's some cool stuff that could come from that. But my instinct listening to what you're saying is that by using real historical scenarios and constructed counterfactual scenarios, you could actually develop a reinforcement learning agent. It would just be an attacker model.
Yeah, it's kind of like penetration testing. Like if we can find the exploits, then we at least we know what they are. We illuminate the exploits, and then we can sort of do some comparison into the underlying model of quadratic funding and say like, is this an obvious why this exploit exists, or is it completely not obvious?
Yeah, I agree with that. It makes sense. I think it's pretty cool. I think the trick though is that if you're looking into reinforcement learning, most of the meat of it comes from the game that you create and the measure of the utility function. And then after that, the reinforcement learning at this point has been reduced to use these packages and tools, and poof, the answer pops out. But like, what is the answer you got the answer to? And that's actually baked into how you defined the game they were playing and the scenarios, so to speak, and the utility function they had. But thinking about it in terms of the cadCAD models and the actual outcomes in the quadratic funding, I would argue it's probably feasible using some of the research infrastructure that we've already built.
Cool.
Yeah, I'm down to sit down for a day and try to crack down on the MDP, like just model as an MDP and see where it goes from there.
Awesome. That would be fun.
Yeah, I definitely am interested in that topic too. I have like background in that type of stuff, sort of like attacking models and then defending against them. And I think pretty well described exactly like how the research would go, but I still think there's like some interesting stuff you could learn.
Very cool. Awesome. Well, yeah, I think there's a lot to explore here. So glad we had this opportunity to explore all of the exciting initiatives coming out of the Token Engineering Academy research group. And it seems like we will need some kind of spin out working groups if it's a bunch of academy participants collaborating on specific models, or these spin out math working group. Yeah, happy to make time, and of course the sessions we have already booked are of course available. But there's definite opportunity for async work on some of these initiatives as well. So yeah, we can keep the Discord channel as a place to touch base. I'll drop in the notes and the recording from this call, and yeah, happy to discuss further async. And we will be having these open hacking and open academic, or sorry, the open hacking session is next week as well. The next one of these sessions will be 2 weeks from now, and that's all in the. Yeah, go
This
ahead.
session, I think we should reserve as a kind of, office hours for the research planning. And, obviously people can reach out in advance if they have agenda items they want to hit. We talked a bit about the, convex optimization, linear algebra, algebraic graph theory stuff. We talked about the reinforcement learning stuff. I think both of those are good topics for, sort of research planning and discussing of methods and sharing knowledge, and even like in some bits maybe even pulling in some materials and talking about it in more detail to help people get on closer to the same level in those topics. But if I had to sort of recommend, I think we should use these sessions sort of like office hours with an agenda set like loosely in advance, similar to what we've done for like the One Hive sessions, where the goal is to have a sort of community driven, but then we have the sort of Danilo, myself, and maybe others depending on the topic coming in to provide like support, answer questions or recommendations, but still keeping it largely driven by what the community wants to work on.
Yeah, absolutely. And that's actually a really good point. There are some other kind of open collaboration modeling sessions going on. One with the One Hive community, Luna Swarm. There may be some interest of people. We're talking about like upskilling and kind of like learning the language of all of these multiple intersecting disciplines. So definitely these skills can be applied in multiple different areas. So there are some other open community explorations involving CAD and kind of this network science, and yeah, a lot of the same concepts. So happy to invite anyone here who is interested in this stuff to participate in any of these other open collaborations too. They can be found on the Token Engineering calendar or the cadCAD calendar. And if you're really interested, I can shoot you a link, or it's all in the Notion document that's in the link repo for everything going on in this initiative. So share some of those in the channel again. If anyone needs anything in particular, please feel free to reach out and DM me, and I can hook you up with some links to get you more information. But I think that's all for today, unless there are any other final questions or closing thoughts. Good to let everyone else head off to their next call.
Jeff, really quick. So I arrived a bit late in the beginning. Where can I find that document so I can add just some of my notes on my questions?
I will drop it in the channel right now.
Thank you very much.
Thanks, guys. Bye-bye.
Cool. Thank you so much for today.
Thanks, everyone. Bye.
Yeah, thanks
Cheers.
everyone. Bye bye.
Bye.
See you later.
Thank you.